Okay, so we're looking at that picture I took from my backyard there of that tree branch. And I'm going to try to model this with a quadratic function. So it looks like a parabola to me, close enough to where I feel comfortable modeling it as a quadratic. Keep in mind when we're talking about things in real life and nature, when we're talking about actual data, things are not always perfect. So you're using what we know to model these things as functions. So first off, let's make sure we're talking about the same thing here. So I kind of have my parabola right about there. Okay, and again, not perfect, right? But that's enough to kind of work off of. And then I want to get some axes here. So I'm going to use as my origin where that tree comes up out of the ground. Okay, so I'm going to make my 0, 0 right about there. Okay, which means obviously my x-axis then, pretty simple, straight across, basically ground level, right? And then my y-axis, I'm going to try to stick to the trunk of that tree there as much as possible. And that's going to be my y-axis. Okay, and then what you need to do from here is you're working to come up with a couple of points. So the first point, as you know, that is most critical is our vertex. And vertex looks to be about right there. Okay, and I'm going to fudge my numbers a little bit just to make sure we're talking whole numbers to start. So that looks like it's about 5, and then 5, 10, 15, 20, 25, 30. So about 530 if I'm going by 5s on my grid here. So I got a vertex at 530, and then I need to pick another point to work with. Again, try to make it easier on yourself, pick some whole numbers. So I'm going to use that point there as my second point. And that looks like 5, 10, 15, 5, 10, 15, 20. Okay, so that's really what I need to get started with some algebra here. So I have my vertex, as I said, is at about 5 and then 30 feet up. And that's what we had talked about when we were outside there. That, remember, is my HK. Okay, and then I'm going to pick another point to work with at about 15, 20. Okay, so that's an X and a Y. So pretty simple right there. All right, that's really all that I need to work off of, okay? So remember, your vertex form is y equals a times x minus h squared plus k. So, I know everything here except for my a. So that's what I'm going to be looking for. My y value is a 20. My x value is a 15. My h is a 5. And my k is a 30. All right, and now I'm just going to kind of start to work here. So 15 minus 5 is 10. Okay, that gets me here. I'm going to subtract that 30 over. I'm going to square my 10. That gets me here. And then divide out by 100. That's going to give me a negative 1/10 for my A. And the negative should make sense, right? My graph there is opening down. Okay, it's a negative 1/10, which would be a vertical shrink, which this does appear to be a little bit. Okay, it's a little bit wider than typical. Okay, so that then allows me to get to my vertex form. Right there. Okay, so that's your vertex form already. Next thing we want to do is, well, there's a couple things you can do. Obviously your vertex jumps out at you there, the 530. You now have an A value to work with. And then you can also go from here into quadratic form. And this is something that we did early on, kind of going from when we talked about vertex form in terms of transformations and graphing. and then getting into quadratic form. And all I need to do is multiply this out. Okay, so I'm gonna leave that negative 1/10. Remember to do x minus 5 squared. It has to be x minus 5 times x minus 5. So I'm gonna expand this here. That's gonna be an x squared minus 5x minus 5x, so that's a minus 10x plus 25. And then you still have the plus 30 there. Okay, I'm going to go ahead and distribute my negative 1/10. So negative 1/10 x squared. Negative 1/10 times negative 10 is a positive 1x. And then this would be a minus 25 over 10. Now, since I know I'm going to have to add that 30, and I know I'm going to need a common denominator of 10, just want to make that 300 over 10. Clean it up a little bit from there. That's going to give me 200 and so one of those should be a plus there, sorry. So that's plus x, and then this would be a 275 over 10. Now, since we're talking about real numbers there, right, let's leave that as it is. But let's go ahead and make this a decimal because that'll make a little bit more sense for us. Okay, so you have quite a bit here. Okay, we have our y-intercept right there. Should be the 27.5. Let's take a look on our graph, see if that matches up. And that's pretty good, right? So that 27.5, get that back in gold here, would be right about there. And just below the 30, so that kind of matches up with what we're talking about on the graph, so that's good. We have a vertex, we have a point, we have right here our vertex form. And we also have right here now our quadratic form. So we have quite a bit of information already. The vertex, as we have said, is pretty important. We have the vertex form, we have the quadratic form, we have the y-intercept. We can analyze that graph and break it down, which we'll do here in a minute. Really the last piece of algebra you have to work with here is that we want to be able to find our x-intercepts. Remember, when you're looking for your x-intercepts, which is your roots, your solutions, you want to solve those equations. So I'm pretty close there with my vertex form already to completing the square. So I'm going to pull that down. Okay. Give myself a little more room to work here. Sorry if my page is moving all over the place. And we want to factor. So we're, again, pretty close already to completing the square. So I'm going to subtract 30 from both sides. Keep in mind that we're saying y is 0 because we're solving for the x-intercepts. Okay, so we want to make that y 0. So subtract 30. And then we're going to want to multiply both sides by a negative 10, which is going to give us now a positive 300 over there. That clears the negative 1/10 and just gets me x minus 5 squared. And here's what I was talking about, where we're basically already completing the square because we had that in vertex form. Take the square root on both sides. That's plus or minus 300, x minus 5, and then add 5 to both sides. My dog's whining here, sorry about that. Okay, now that still doesn't mean much as a number. 5 plus or minus the square root of 300. So this is one of those instances where go ahead and go to a decimal. Okay, and that is 17.3. And then remember, you're talking both plus and minus. Okay, so 5 plus 17.3 is a 22.3. And that's one of your x-intercepts. 5 minus 17.3 is a negative 12.3. And you can just do these on the calculator. Okay, and those are going to be my x-intercepts. Okay, now we've gotten quite a bit of information here already, but let's take a look. Does that match up with our graph? So 22.3 and negative 12.3. Well, if I go back, let's get our yellow pen back here. This is one of our x-intercepts, and that's what, 5, 10, 15, 22. That seems pretty fair. And then on the left side, negative 5, negative 10, could be negative 12.3. So you can really kind of see where this starts to match up in terms of what the reality of that graph is. Some of the other things we can do, obviously, is once we have that graph, pretty obvious to determine that that vertex is going to be a maximum point, right? We can talk about domain and range a little bit. Our domain is going to be, really in this case, you could probably stop it at the tree trunk if you wanted to, and just talk about the actual size of the tree limb. So I don't really have any x values on my tree limb past 0. And then my tree branch ends 5, 10, 15, let's call it at about 20 feet out. So in most cases when we're talking about a parabola, we have a domain that would be all reals because it continues right and left. But in this case, since we actually have something there, we can use that to give ourselves a domain. And we can also use it to do our range a little bit as well. And same thing, if we use the actual where that comes off the tree, and that should be our y-intercept, right? So we have a range, and actually if we look at the lowest part, it's probably pretty close to that, 5, 10, 15, 20, about that 20. So we have a range going from 20 and then up to 30. Okay, so you could use that for your domain and range, just because we actually have the tree branch there that we can talk about. The other things we talked about is where our parabola is increasing, where it's decreasing. And remember, that's always going to be hinging on the vertex. So we are going to be increasing. In other words, as we move from left to right, our y values are increasing anytime x is less than 5. And then it's decreasing anytime x is greater than 5. So that is a pretty complete breakdown of parabolas there. Okay, and that's what you are going to be tasked to do. And this is what we will get evaluated on. So here's your procedure. That's my dog again, sorry. First thing you got to do is obviously go find a parabola. Okay. And then you're going to really kind of analyze it and break it down. Okay. So first thing is your vertex should jump out at you. So go ahead, find your vertex. And then along with that, I'm going to also remind you to just find another point on your parabola. Okay. So find your vertex and a point. That's going to lead you right into getting your vertex. Well, actually, I'm sorry, before the vertex, you're going to want to find A then by plugging in your vertex and the point. Then you're going to get your vertex form. Once you multiply that vertex form out, you're going to be able to get your quadratic form. And keep in mind here, our vertex form is the A times x minus h squared. Get that on the right side of the parentheses. And then your quadratic form, ax squared plus bx plus c. Okay, and then once you're in quadratic form, your y-intercept should jump out at you. Okay, so that'll be just your C value. Remember, when you're talking about quadratic form, that's your C value right there. Go ahead, then take your vertex form back and solve it. Or you can use quadratic form and solve it by factoring, quadratic formula. If you don't actually have it going across the x-axis, then you're going to have some imaginary roots, which is okay too. Either way there is going to be fine, but go ahead and find your x-intercepts. And then go back and just analyze your graph. So is it a max, is it a min? Okay, find your domain, find your range. And that's going to get you in pretty good shape. All right, so I'm going to have you guys turn this in by Monday. Okay, so I just want you to video yourself, turn it in on Monday, and then this will kind of be our assessment for the meantime. All right, hope you guys are doing well. Had some fun with it. Looking forward to what you guys come up with.